So today we are going to start Chapter 1, Section 1. Today we're going to learn a bunch of definitions and a lot of ways to name the different things that we're going to be using throughout the course. So really what we're doing is laying the foundation for the course today. So the first thing we're going to do is define what a point is. And a point is a single dot. It's the simplest figure in geometry. You can name a point with a capital letter. All geometric figures consist of points. Now, a point has no size to it. So it has no size, and it also has no dimension. Now, this last bullet point, all geometric figures consist of points. So later on in the course, we're going to be starting to talk about triangles. And when I refer to a triangle is made up of 3 points. So if I were to put 3 little points on my paper here and label them with a capital letter, A, B, C, and then connect these 3 points, I have just formed a geometric figure called a triangle. So all geometric figures are composed of or made up of points. So a point's always going to have a little dot next to it. The next definition is a line. And a line is a geometric figure consisting of at least 2 points. It extends in 2 directions without ending. You can name a point, you can name a line with 2 points or a single lowercase letter. That lowercase letter is usually like in italics. Through any 2 points, there is exactly 1 line. A line has 1 dimension. Now, if you notice the picture here, and I know they're kind of tiny, but at the ends of this line are arrows, indicating that that extends forever in both directions. Now, here's where it gets important about the naming of these different figures or different things in geometry. When you name a line, you're going to name it with 2 points, so 2 capital letters. You either need to put the word L-I-N-E in front of the 2 points on that line, or you can draw a picture of a line on top, or again, you can name it with a lowercase letter. I know this letter over here on the side looks like a 1, but it's actually an italicized letter L. So this is line, lowercase letter L. It can be any letter. It doesn't have to be L for line. It could be any lowercase letter. So I could have another line here. I could put 2 points on it. Now I could actually have 3 points on it, but when you name a line, all you use are 2 of the points on the line. So I could call this line XZ, and again, either write the word L-I-N-E in front or put a picture of a line on top of the 2 points. I could also name it XY. It doesn't matter which 2 points because remember, it goes beyond Y because of the arrows on top of those capital letters. It extends forever. Now, the order when you name a line doesn't matter. So this line AB here, I could have also called it BA. So the order of the letters doesn't matter when you're naming a line. Same thing here, I could have called it ZX or YX, any combination of the 2 points that are on that line. And if I called this, let's say I called this line up here, the XYZ, let's say I called it letter D. So I could also have called this, and if you're going to use the lowercase letter, you're going to write the word line in front of that lowercase letter. So a plane, a geometric plane is suggested, or a good example would be like the floor, a wall, a tabletop. But what you have to imagine is that floor goes forever. It doesn't end. It doesn't have any thickness. Same thing with the tabletop. All we're trying to look at it as is some kind of four-sided shape that goes on forever. So a general thing when they're showing something in a book or on a piece of paper, when they want to show you a picture of a plane, it's usually a quadrilateral. And a quadrilateral is just a four-sided shape. Later on, we will have a chapter all on quadrilaterals, and you probably know many of them, squares and rectangles and parallelograms, and we'll cover a whole chapter on quadrilaterals. Now, a plane has no edges. Remember, it's going to keep on going, even though the figure below has edges, because I can't show something that goes on forever on a piece of paper. You can name a plane by a single capital letter or 3 or more points that are in the plane. Now, in this red plane here, I don't have any points yet, but I'm going to add 3 of them. So I can either name this plane M, and you can only name it with a capital letter that doesn't have a point next to it. So notice there's no dot next to the M. So this is just naming plane M. M is not a point. But if I add some dots here and put capital letters next to them, A, B, and C are points. And I can also name this plane M and also call it plane A, B, C. Sometimes they're going to name a plane with 4 letters, but you need at least 3 to name a plane. And there is no shortcut or anything with drawing a picture on top. You have to write out the word plane in front of those 3 points. A plane has 2 dimensions. The next slide is space, collinear, and coplanar. The definition of space is just the set of all points. Collinear means that all the points are on one line. So if I were to draw a line here and add some points to it, A, B, C, I could say that points A, B, and C are collinear because they are all sitting on the same line. However, if I were to add a 4th point and put it on top and call this point D up here, then I would say that points A, B, and maybe D, I don't even have to list C, A, B, and D are non-collinear because D is not sitting on the line where A and B are. So when they're not sitting on the same line, they're said to be non-collinear. When I see the word coplanar, this tells me that all the points are in the same plane. So again, if I draw my quadrilateral here, sort of looks like a parallelogram. And if I add some points to it, let's say I put in here point D, E, and F, I could say that points D, E, and F are coplanar because they're all sitting inside this quadrilateral shape. They're all in the same plane. Now, if I were to draw in a 4th point, and let's say I put the point up above here, and let's say I call this point G, then I would say that points D, E, F, and G are non-coplanar because point G is on top of that plane. So I'm going to go ahead and show you, like if I take a piece of paper and let that represent a plane, and how I could put a point on top of it. On the next slide, we're talking about segments. And in this picture, the line segment or segment AB consists of endpoints A and B and all the points on line AB that are between A and B. So for example, a segment stops, whereas a line goes forever. So for example, even if I drew a line here and put points A and B on it, when I'm trying to refer to a line, I put the 2 points and draw the picture of the line on top. When I'm referring to a segment, I put a line on top without arrows because the segment is only referring to all the points in between A and B. It gives me a beginning and an end. Whereas the line, it's this entire thing, and it goes beyond the A and the B because of the arrows on the end. Just like with the line, the order of the letters doesn't matter. So just like before, I told you we could also call that line BA. Same thing with the segment. We can also call it BA. Now again, you can also write the word segment in front of the 2 points or draw the line on top. Now, sometimes you're also going to see a segment without the line on top. So if you only see 2 capital letters with no picture on top, they're also referring to a segment. But most of the time, the questions will have that single bar on top, indicating that it's a segment and not a line. Now, if I had another point here, and say I called it C, C, I could say, is on segment AB because it's in between points A and B. So array will be written as, and I know it's kind of hard to see here, but it's got an endpoint and then it's got an arrow on one side. So this is how you would write array with the 2 capital letters, and it's just got an arrow on one side of it. The first letter tells the starting point, and then the second letter where the arrow is on top of it tells you the direction that it goes on forever. It's unending. Now you can, depending on what way your ray points, that's what you would do here. So for example, if I have it pointing this way, I would describe this ray as AB. The first letter is where it doesn't have the arrow. And then you can see that it goes unending in the direction of B. Now, even if I put it like this and put B here, this is a totally different ray, I would still name this. The first letter is where the closed circle is, and then the direction where the arrow is pointing would be your second letter. Array, the order of the letters matters. You can't switch it up. So the order of the letters matters with array because, again, the first letter is always where the closed circle is. Now, if I pointed it in the other direction, and let's say I had BA here, I'm still going to describe my ray where the closed circle is first, and then point it in the direction where the arrow is. So even if it points to the left, I still have to put where the closed circle is as my first letter. That's the beginning point. So on the next slide, it's talking about opposite rays, and it says if point C lies on line AB between A and B, then ray CA and ray CB are opposite rays. So if you notice, they both have an endpoint in common. They both start here at the letter C. So for the first one, CA, let me do maybe another color here, green. Okay, so for CA, it starts at C and then it points in the direction of A. For CB, this one's going to start at C and then go in the direction of B. Notice they both start at the same point. They have the same endpoint, but then they point in opposite directions. And these are called opposite rays. So the word intersection means to meet or cut through. So for example, when you start learning to drive and you're out on the road, where two roads meet, that is called an intersection. So maybe where you see a four-way stop or where you see a street light, that in real life is an intersection. And that's where the two roads are meeting or they're cutting through. So when we talk about the intersection of two figures, we're talking about the set of points that are in both figures. So in this figure, anytime you see, or any figures, anytime you see dashes in a diagram, they're going to be indicating the parts of the figure that would be like underneath it or behind it, that would be hidden from view. So, and I'll show you this with some pieces of paper here and how I can intersect them and how maybe you might not see something because it's in the back. However, let's talk about the intersection of two lines. So when I have two lines, and when they cut through or meet, the intersection of two lines is always a point. So two lines intersect at a point. And when I was describing the floor and the ceiling, or sorry, the ceiling and the wall, remember I told you that two planes intersect at a line. So in this figure here, this is an example of two planes, and their intersection is this line, K, where they're both meeting. So two planes, their intersection is always a line. Now, because planes go forever, their intersection will never be a line segment, it's always a line. Because lines go forever, and so do planes. Okay, so we're going to go through some examples. Now, for these examples, what you're going to find throughout the year is sometimes you're going to get questions where a picture or a diagram is given to you. Other times, sometimes you don't get a picture and you're going to have to draw it yourself. Now, I am not grading you on your artistic ability, so whenever you're taking a test or a quiz or doing your homework, if it helps you to draw a picture of whatever is happening in the question, you can do that in your work. I'm never going to ask you to draw something and then grade you on your drawing. So just, keep all of that in mind. Now, sometimes the pictures are provided, and what you're going to see on the next slide, sometimes when you're given the picture, it makes the question a lot easier. Now, these are just simple true, false. I'm not asking you to justify, but we're going to explain when it's false. We also give you types of questions where I'll give you a statement and you're going to have to tell me, is that sometimes true, always true, or never true? So those sometimes, always, or never questions, they're sort of like true, false on steroids. They're a little bit harder than just a simple true, false. But these are just simple true, false. But coming up, you're going to see in the homework, we're going to have sometimes, always, and never questions. So let's go ahead and go through these examples. It says line PF ends at point P. True or false? False, right? Because what do we know about a line? Does it end? No. So this one would be false because lines do not end. Number 2, point S is on an infinite number of lines. Now this one's a little tricky. So if I draw point S here, if I try to start drawing lines through this, I could draw it this way, and you may think, I've got a limited number of lines I could draw through this, but actually there are an infinite number. Because not only am I doing it just flat here, I could go sideways and up and down. So this one is actually true. There are an infinite number of lines. I could go through at all different angles and still draw a line there. The next one, a plane has no thickness. True or false? True. This is right from the notes, right from the slide. The next one, collinear points are coplanar. So, okay, it is true. Yeah, it's sometimes true, but in this case, it's just true or false. So because it's sometimes true, this one is true. So the points could be all on a straight line and still be in a plane. But when we normally name a plane, we're looking for 3 non-coplanar points. Or 3 non-collinear points, sorry. Okay, planes have edges. This one's false, good, because planes go forever. 2 planes intersect in a line segment. False, good. Now, if this statement would have said 2 planes intersect in a line, then it would have been true. Because remember, planes go forever, and so do lines. 2 intersecting lines meet in exactly 1 point. This one is true. Because again, you intersect them, they will never meet in more than 1 point. So it's always exactly 1 point. Points have no size. True. And then line XY, and the word denoted means like another way that you could write it. And it looks like when I was typing, my thing shifted a little. The X and the Y should be right under that arrow. So remember, you can name a line with the word L-I-N-E in front, or put the 2 capital letters underneath a picture of a line. And remember, the order of the letters does not matter. So this one is true. Okay, so for this one, it's asking us to use the diagram. Now I'm going to add a few things to it just to clarify which letters here are points and which one are names of planes. So if the capital letter does not have a dot next to it, then it's the name of the plane. So I'm going to leave N as the name of the plane and M as the name of the plane, but I'm going to put a point next to Y, a point next to A little dot next to X, and then I'm also going to put a little dot next to the P. So Y, A, X, and P are all points. And when you take a test or a quiz, it'll be clear that which ones are points and which one are naming the plane. So the capital N and the capital M, they are not points. Those are the names of the plane. So let's go ahead and answer the questions. P is in M. So is point P in plane M? No, it's not. Good. This one is false. Because if we outline plane M, do it maybe in blue, plane M is here, and point P is down here. It's not in plane M. B, and this is a lowercase letter, it's naming that line here. B is in M. And we just outlined it, so this one is true. Line XY contains P, and here they're referring to P as a point. So XY is right here. And you can, since they're calling it line, we can extend it. So does line XY contain point P? No, it does not. It's false. Plane M contains line XY. Yes, it does. Because again, remember, you're assuming that that plane goes forever, even though I just outlined it in blue. So this one is true. And then point A is on line B. That one is also true. And then points A and P are in plane M. That one is false. A's in M, but P is not. We already determined that up at number 1. And then plane N contains point P. Well, here is plane N, and we can see that point P is in it. So that one would be true. So this first homework is going to go, it's going to have a lot of naming things. Just remember that you put the correct symbols or type the word line in front, or you don't have to type, you're going to handwrite it, the homework, or you could put the word segment if it's a segment, things like that. It'll help if you can get used to just drawing the little picture on top. When we were in the midst of COVID and everybody was taking tests and quizzes on Canvas, a lot of people weren't familiar with the equation editor. So when they would name a line, they would type in the word line on Canvas. Or if they wanted to refer to a segment, they typed in the word segment. And then they didn't have to worry about drawing the picture on top of the capital letters. So either way is a good way to name these things. But you need to be able to recognize it if they don't spell out the word.